Day 16 of 75 in our DSA and Python challenge. And today we're killing nested loops for good. You know the moment. The interview problem says find duplicates or most common element. Your hands type a double for loop, and somewhere in your brain a voice whispers, there's a faster way. That faster way is frequency counting, and by the end of these 5 minutes you'll reach for it on instinct. Let's turn some O in superscript 2 garbage into clean O in. Here's the core idea. A frequency map is a lookup table you build once and query many times. Instead of rescanning the array every time you ask, how many of these are there? You pay one pass up front, store counts in a dict, then every lookup is O1. You're trading a little space for a lot of time. That single trade-off is the whole pattern. When a problem mentions count, duplicate, most frequent, or group, that's your trigger to build a map first. Let's build one from first principles. The manual way, counts equals, loop through your items, and for each one write counts, x equals counts.get, x, 0, plus 1. That get with the default of 0 is what saves you from a error on the first citing. Beginners forget it and crash on empty or all new input. Next level up, from collections import default dict, then counts equals default dict. Int lets you just write counts x plus equals 1. Missing keys auto-initialize to 0. Cleaner, same complexity. But Python already wrote this for you. From collections import counter, then counts equals counter my_list. Builds the entire frequency map in one line. Counter is a dict subclass, so everything you know still works, plus you get superpowers. Counts.most_common, 3, hands you the top 3 elements by frequency, already sorted. Counter even does arithmetic, subtract one counter from another to diff2 datasets. Rule of thumb, hand roll a dict when you're learning or need custom logic. Reach for counter in real code. Problem 1, character frequency, the foundation. Counter, Mississippi, instantly tells you S and I appear 4 times each. Problem 2, anagram check. 2 words are anagrams if they have identical frequency maps. So counter, listen, equals counter, silent, returns true. That's it. No sorting, no nested comparison. O, in, instead of O, in log n. Counter equality compares counts directly, which is exactly the question, are these the same letters in any order, was really asking. Problem 3, top k frequent elements, a genuine interview favorite. Naive approach sorts every element by count. O, in log n. Better, counter, nums.most_common k. But if you want to show off complexity reasoning, use a heap. Import heap, build your counts, then heap.enlargest, k, counts, key equals counts.get. That's O in log k, not O in log n, because the heap only ever holds k elements. When k is small and n is huge, that difference is real. Interviewers love hearing why that bound holds. Now the edge cases that silently wreck you. Empty input. Counter is an empty counter and .most_common returns an empty list. Handle it before you index 0. First non-repeating character. Do 2 passes, build the counter, then loop the string in order and return the first jar with count 1. This works because Python 3.7 plus dicts preserve insertion order, the guarantee that makes ab return the right index instead of a random one. Don't assume order on older versions. One pattern that hides inside frequency counting, prefix sum maps. For subarray sum equals k, you store running sum counts in a dict and look up frequency current_sum k. That complement trick handles negative numbers and zeros that simple counting would miss. Same hash map idea, applied to sums instead of values. The lesson, once you see the map, you start spotting it everywhere. Count, group, complement, all the same muscle. Day 16 done. The takeaway, when you see count, duplicate, most frequent, or group, build a frequency map before you write a single loop. Subscribe for day 17, where we go deeper.